In this video, I will be discussing about Favorskii rearrangement. So Favorskii rearrangement involves this rearrangement involves breakage of CX bond. So the starting material over here is alpha halo ketone. Starting material is a alpha halo ketone. And in presence of a base like any sodium methoxide or sodium methoxide or potassium hydroxide, it gives an ester. So let's take the mechanism. Let's see the mechanism, how it works. So if you have an alpha haloketone like this, you have an alpha haloketone in presence of a base like sodium methoxide. And in this reaction, starting material, there should be a acidic proton over here. That means analyzable proton. There should be analyzable proton. This proton is acidic as it is present in the alpha position of a keto. Okay. So in presence of NaOMe, this NaOMe will abstract this proton, right? So this will abstract this proton. So it will give a negative charge over here. Now this negative charge will attack over here, and this X, this halo group, will leave. So we will get a free member system like this. And the next step, this nucleophile, OE minus nucleophile, will attack the carbonyl, and here ring opening will take place. So in this case, since both R groups are same, so the ring opening can take place from either of the side. So it doesn't matter. Let's say ring opening takes place over here. So we are ending with R group, and we are getting over here CO2. So this is the product. So we are starting from alpha haloketone. This is the alpha haloketone, and we are ending with our ester. Okay. Now here in this case, we have both the R groups which is same, or we have one R group in this side, another one on the other side. Let's take, if you have a system, if you have an alpha haloketone, where in this side we have a one R group, and where in this side we have two R groups, and over here a halo. Okay. So in this case, if we treat it with NaOMe, same this proton will get abstracted, will form a negative charge over here, it will attack over here, and this X will depart. Right. So we are getting this cyclic state. Okay. Now what happens? Now if we treat it with OMe minus, so there are two possibilities. Okay. So either the opening will be from this side. If the opening will be from this green side, the opening is from this green side, we'll end up with, this is the opening, this is a minus, okay, and this one is R, this is our CO2. Either we will get this one, and if the opening is from this side, if the opening is from this side, then we are ending with R, this is CO2Me, and this is our R over here, a negative charge. Okay. So between these two, as you can see that here we are getting a 3-degree carbanion. We are getting a 3-degree carbanion, and here we are getting a 2-degree carbanion. So as you all know that a 2-degree carbanion is more stable than a 3-degree carbanion. So this part will not form. So this will form, and finally after workup, we'll end up with, when acidic workup, if we do acidic workup, we'll end up with this product. So this will be the product, right? Let us take some other examples. So if we have a cyclohexanone, and in the alpha position we have some bromine group. Then in presence of sodium methoxide, we have an acidic proton over here. This will get abstracted. Okay, it will get abstracted, and we'll get a negative charge over here, and we're getting a this. So here they will attack, and the bromine will leave, and we'll get this type of system. Now you have the OMe minus. So OMe minus will attack the carbonyl, and it can open up from either of the side because both are symmetrical. So we'll end up with a 5-member ring with a ester group. Fine. Next example, if we see, if we have this type of system, if we have a benzene type system, and we have alpha halo, and here we have the proton, right? This analyzable proton. So in presence of NaOMe, what will form? Will form this type of system, because the negative charge will push here and the Cl will leave as a Cl minus. We'll get this type of product, this type of intermediate. Then after that, if we treat it with OMe minus over here to attack OMe minus, so again the opening can be from one of the side. So if it opens from this side, so we will end up with here a negative charge, and here we'll end up with a CO2 Me. But if it opens from the other side, let's say if it's open from this side, if it opens from this side, then we will get, here we'll get a CO2 Me. This side was 1, 2. Here we have total 3 carbon. So here a negative charge. So between these two, we can see this one is more stable. This one is more stable because this negative charge is, this can take part in conjugation with the benzene ring. So this is a more stable carbanion than this one. So this will not form. So after workup, we'll end up with this product. After workup, we'll end up with this product. Next, we'll see if you have a system like this. You have a system like this. So we have a keto group over here, another cyclic ring, and over here halo. So if we treat it with a base KOH, so OH minus will abstract this proton, and it will attack here, and this will go here. So basically we are getting like this. After that, the OH minus will attack here, and this can open from either of the side because both are symmetrical. This is opening from this side. After workup, we are getting CO2H. Okay. And next example, the last example, what we will see is that, let's say if we have this type of system. So here we have an Me group and we have a Cl, keto, we have PA. Now this one as an alpha haloketone, but the problem is that it does not have any alpha hydrogen that can be abstracted. That means it is an unanalyzable ketone. So this reaction will be like benzylic type. This is benzylic type Favorskii rearrangement of unanalyzable ketone. So this ketone cannot be analyzed due to the absence of alpha hydrogen adjacent to it. So what will happen if we treat it with a KOH minus? It will directly attack as a nucleophile. So we will get this one. This is O minus. This is OH. This is pH, and this one is Cl minus. So what will happen? This O minus will push here. This phenyl will get migrated, and Cl minus will leave. So we will end up with this type of product. We have a phenyl group over here, and we have a carboxylic acid over here. Okay. So this is all for the video, and thanks for watching.